Basic principles in building conveying systems.
Basic principles in building conveying systems.
Building In buildings, systems may include passenger and freight elevators, dumbwaiters, escalators, moving ramps and walkways, and lifts for people and wheelchairs. Business and industrial operations may require specially designed material handling equipment, hoists, cranes, and scaffolding. Facilities on large sites may have monorails and other types of people movers. Manually operated elevators were first used for lifting freight in warehouses and manufacturing plants as early as the 1600s. They began a simple rope or chain hoist that moved an open platform. In 1852, Alicia Otis introduced the safety elevator, which prevented the fall of the elevator cab if the cable broke. Otis' safety device consisted of a knurled roller located below the elevator platform and a governor device that monitored descending speed. The safety device lacked when the elevator descended at a higher than normal speed. It was this safety feature that made the elevator a safe conveying system for building occupants, which then made skyscrapers achievable.
Elevators.
In this section we will discuss about elevator technologies, basic components of an elevator system, basic types of an elevator, variations of basic types of elevators, classifications of elevators, elevator design criteria, elevator code standard.
An elevator is a conveying device used to move people or freight vertically, usually between floors of a building. So elevators are vertical transport systems that transport people between floors of a building or even stops go from the ground level of a building up to the higher level or vice versa. An elevator system consists of a hoisting mechanism that is connected to a car or platform. This car or platform then moves vertically, in most cases, on guides that are attached to the fire-resistant sides of a hoistway. So in this image, we can see a first floor entrance to two elevator cars.
The two basic types of elevator technologies, hydraulic and traction. Hydraulic elevators. Hydraulic elevators use a fluid-driven hydraulic jack to lift the elevator car. Hydraulic elevators, it consists of a hydraulic jack, cylinder and plunger, a pump powered by an electric motor that increases the pressure in the hydraulic fluid. A control valve between the cylinder and reservoir controls the pressure in the jack and the fluid reservoir tank. It operates when the pump draws oil from the reservoir, pressurizes it, pushes the oil through the oil line to the jack, and driving the elevator car upward. A release of fluid through the control valve and back to the reservoir decreases oil pressure, which allows the plunger and connected elevator car to move downward.
Shown in the picture is the bottom side of a conventional whole hydraulic elevator. The elevator car is made of the cab, which carries the passengers, and the platform, which consists of a structural framework. The hydraulic plunger connects to the center beam of the car platform. Behind and alongside the cylinder to the left is the traveling cable. Guide rails are evident on the left and right side of the hoistway walls. Hydraulic systems are more affordable to install, less expensive to maintain and repair, better for transporting heavy loads, intended for low-price applications.
Basic components of a hydraulic elevator system are shown in figure below. Traction elevators. Traction elevators have a drive machine with an electric motor and pulley-like groove drive sheave that holds cable that move the elevator car up or down. Steel cables called hoisting ropes support the elevator and counterweight during normal operation. There are typically 3 or 8 cables for each elevator. Most traction elevators generally use wire ropes that are 1/4 to 1 1/4 inches, that's 6 to 32 millimeters in diameter, and are composed of multi-strand soft steel wire wound around a hemp or polymeric core. Traditionally, the 8 and 19 wire rope, that's 8 strands with 19 wires per strand, pattern was used, but this is being replaced with modern patterns. Wire ropes must watch the drive sheave perfectly to ensure that they have a long life. The counterweight is a set of steel or iron plates fastened to one end of the hoisting rope that counterbalances the car. It is weighted to be equal to the car's dead weight plus 40 to 50% of car load capacity. The weight of the car and counterweight presses rope into grooves on a drive sheave. The friction between the hoisting ropes and the drive sheave is used to move the elevator car with a cable. Variation of basic type of elevators. Conventional, that's the hold one hydraulic elevator. Traction elevator, holeless hydraulic elevator, roped hydraulic elevator. On a conventional or the hold hydraulic elevator, an in-ground hydraulic jack lifts the elevator car. A long plunger requires a deep hole below the bottom landing. The hole is usually drilled into the ground and cased with a plastic or metal casing before the building is erected. A telescopic hydraulic elevator has a telescoping plunger consisting of concentric tubes that slide within one another, allowing a shallow hole below the lowest floor. Conventional hold hydraulic elevators are the most balanced type of hydraulic elevators configuration because the lifting point of the bottom of the elevator car is centered. Holeless hydraulic elevators have 1 or 2 jacks situated beside the rails that lift the platform. Because they do not require holes to be dug for the hydraulic jacks, they are referred to as holeless. A dual or twin jack configuration can have 2 front and rear entrances, while the single jack configuration can only have 1 front entrance. Roped hydraulic elevators use a combination of both ropes and hydraulic power to raise and lower cars. They typically consist of cantilever car that is lifted by ropes that pass over a sheave, the pulley, fastened to the top of a hydraulic plunger. As the plunger rises, so does the elevator car. Single rope configuration cannot have rear entrances. Classification of elevators: passenger elevator, freight elevators, dumbwaiters, and man lifts. Passenger elevators are designed to carry people and small packages. Freight elevators are used to carry materials, goods, equipment, and vehicles rather than people. A dumbwaiter is a small freight elevator used to transport lightweight freight such as food, laundry, books, records, and other small items. A man lift is an elevator installed in a variety of structures and locations to provide vertical transportation of authorized personnel and their tools and equipments only.
Elevator Code Standard. Codes are established by the American National Standard Safety Code for elevators, dumbwaiters, escalators, and moving walks, ANSI or ASME A17.1, and local building codes. Standard sizes and shapes for elevators are determined by the National Elevator Industries Incorporation or the NEII. This table shows the recommended capacity and design for passengers elevators in various occupancies.
Type and design speeds for elevators are compared in the table below.
Recommended performance of elevators. An example of elevator loading capacities for passengers and freight elevators. Elevators in low-rise group should serve the lower portion of the building, while elevators in high-rise group travel directly from the main stop to the upper portions of the building.
Escalators.
Escalators are inclined, continuous moving stairs and handrails that transport people from one floor to another. They are used where elevators may be impractical, but use of stairways may be too slow for the anticipated crowd. Common places they are found are in airports, arenas, convention centers, department stores, hotels, shopping malls, transit systems, and public buildings. Escalators have little or no waiting interval, can be used to guide people toward exhibition areas, main entrances or exits, and be waterproofed for outdoor use. Escalators can be used as a required means of egress if they meet all requirements for emergency egress stairways, such as providing smoke and fire protection and a sprinkler system. Escalators can move many more people faster than elevators, traveling at typical speeds of 9,100 feet per minute. Escalators are powered with constant speed alternating current motors. Maximum inclination of an escalator, from a horizontal surface, is 30 degrees, with a standard rise up to approximately 60 feet. Escalator widths are typically 24, 32 and 40 inches wide. Newer escalators have single pieces of aluminum or steel steps that move on a system of tracks in a continuous loop attached to a welded steel truss structural frame. Basic types of an escalator. Step-type escalator, wheelchair escalator, spiral escalator, levitator. Basic types of an escalator. Step-type escalator. Step-type escalator is one of the most common forms of escalators used today. The steps are usually made up of metal. The movement of these type of escalators is upward then flat and then downward, and the vice versa as well. This type of escalator is safer than most other forms of escalators. Wheelchair escalator. Wheelchair accessible escalator is nothing but a normal escalator with special provisions for a wheelchair. In this type of escalators, there is a special attendant. If a person with a wheelchair steps onto the escalator is put in a special mode where 3 steps level out and a platform is formed. Thereafter some spikes come out from the back of the step closer to the lower landing of the wheelchair, thereby preventing the wheelchair along with the person to fall down. Spiral escalator. This type of escalators have curved steps, giving them a fancy sort of appearance. They look very beautiful and attractive and are only manufactured by Mitsubishi since 1985. Levitator. Levitator is the newest type of escalator. This is a free type of escalator that can curve multiple times in either upward or downward direction. In this system, there are 2 escalators which continuously share loops of steps and can allow curve differently. The steps of this escalator are also uniquely built. Basic components of an escalator. Balustrade. The side of an escalator extending above the steps, which includes skirt guard, interior panel, deckboard and moving handrails. 1. Moving handrail. A handhold that moves along the top of the balustrade in synchronization with the steps. 2. Interior panel. The major panel portion of the balustrade located immediately below the moving handrails, made of glass. 3. Deckboard. A decorative capping member of the balustrade of an escalator, which continues in the traveling direction. 4. Skirt guard. The lowest panel within the balustrade, located immediately below the inner deck and adjacent to the steps at a slight gap from the steps. Truss. Assembly of structural steel that supports the weight and load of an escalator. A control panel, drive units for steps and moving handrails and other components are housed inside the structure. Closing parenthesis. Upper machine room, lower machine room. 1. Control panel. Controls stop, start operation and also supplies electric power to the drive unit. 2. Drive unit. A unit to drive the escalator, comprised of electric motor, decelerator, electromagnetic brake, V-belt, sprocket, and other components. 3. Drive chain. A chain that transmits the drive unit's power to the drive wheel, sprocket. 4. Upper sprocket, lower sprocket. Drive wheels installed at the upper and lower parts of an escalator. The upper sprocket drives the steps, while the lower sprocket turns the steps. Other truss parts. 1. Main track. A rail to guide the driving rollers. 2. Trailing track. A rail to guide the trailing rollers. 3. Moving handrail drive unit. A device that indirectly drives the moving handrail at the same speed as the steps via the moving handrail drive chain. Step. The moving platform on which escalator passengers ride. 1. Step tread. The part of the step where a passenger stands. 2. Riser. The upright part of a step. 3. Step demarcation line. A yellow line along both sides of a step to demarcate the proper standing area, thereby preventing passengers from coming into contact with the skirt guard and stumbling. 4. Driving roller, trailing roller. Each step is linked to the step chains via the step shaft and the wheels. The front wheel is called the driving roller and the rear wheel is called the trailing roller. 5. Step chain. A chain, located on both sides of an escalator, connecting the steps and driven by the step chain sprocket. A lower landing of an escalator. Note how the stairs raise at the beginning of the escalator. An emergency stop switch extends from the right handrail. An upper landing of an escalator. Note how the stairs fold in at the top of the escalator. An emergency stop switch on an escalator. 3 basic configurations that are used for most common escalator systems. Parallel. Up and down escalators side by side are close to each other. Crisscross. Stacked and all going in the same direction. Multiple parallel. 2 or more together that travel in one direction next to 1 or more traveling in the opposite direction. Regulation.
Walkways and ramps.
A moving walkway, also known as an autowalk, moving pavement, moving sidewalk, people mover, travelator, or travelator, is a slow-moving conveyor mechanism that transports people across a horizontal or inclined plane over a short to medium distance. Moving walkways can be used by standing or walking on them. They are often installed in pairs, one for each direction. An inclined moving walkway, also called a moving ramp or power ramp, is a moving walkway that transports people on an incline, up to a 12 degrees angle of inclination. Moving walkways are more accessible to those in wheelchairs, as they are usually thought easier to use than getting in and out of small elevators. Moving walks are slow-moving, approximately 1.5 miles per hour, or high-speed, approximately 9–12 miles per hour, horizontal conveyor belts designed to move people. Moving ramps have a maximum incline of 12 degrees and may move people up or down an inclined area. They may be connected together or used individually. Types of walks and ramps. Pallet type. A continuous set of flat metal plates, called pallets, that are joined together to form a walkway, may or may not have rubber added for better traction. Moving belt. Comprised of a mesh metal or rubber belt with a rubber walking surface that move over metal rollers. Components of moving walkways. An inclined moving walkway. A horizontal moving walkway. A pallet-type walkway.
Facility chutes.
A facility chute is a vertical or inclined passage through which objects can be passed through by means of gravity. Chutes are common in older high-rise residential and commercial buildings. This is to allow rapid transport of trash, laundry, mail, or construction debris from upper floors to the exterior of the building, the entry floor or the basement area.
Lifts.
Under lift, there are 5 categories: wheelchair lift, chair lift, platform lift, stair lift, and car lift. Wheelchair lift, a powered device designed to raise a wheelchair or scooter and its occupant to overcome a step or similar vertical barrier, usually 6 feet tall or less. They often are designed to accommodate just one person in a wheelchair or a scooter at a time. Wheelchair lifts are used to move a wheelchair and its passenger from one level to another. Commercial lifts are designed to raise a wheelchair or scooter and its occupant up to 1 story. One type of lift is a steel platform with steel sides, entry and exit gates. The platform is covered with a rubber skid-proof surface and is operated by an electric motor that is controlled by the passenger. The wheelchair lift does not operate until all gates are secure and the wheelchair and its passenger are in place. This lift can be installed in vans, buses, and other vehicles of transportation. A wheelchair stair lift moves the wheelchair and its passenger up or down stairs on a platform with side closures that are attached to a steel rail system that is fastened to the wall or the stair treads. This system can transport up or down on multi-level straight stair. A wheelchair lift in a residential garage. Chair lifts. Chair lifts are a type of aerial lift that consists of continuous steel cable loop string between 2 terminals. The cable continuously circulates between the terminals and the intermediate tower, allowing the chair to move in an opposite direction. Chair lifts are commonly used at ski resorts, amusement parks, tourism attractions, and in urban transport. Platform lifts supply access to decks, porches, stages, and elevated surfaces. Stair lifts. A stair lift will carry a user safely upstairs. To use a stair lift, the user sits on the lift seat. The seat will then transfer the user up or downstairs via a staircase-mounted track. For stairs with turn, 2 lifts are required. Another type of stair lift is for people who have difficulty climbing stairs. This lift has a chair that runs along a steel or extruded aluminum rail that is mounted to the wall or the stair tread. This stair lift is capable of moving around corners and across landings, allowing the passenger to disembark safely away from the top of the stairs. Controls are usually located on the arm of the chair and many have radio frequency or infrared remote controls. Car lifts. A car lift is installed in small parking garages where ramps are not feasible. The platforms are raised and lowered by hydraulically and are connected to steel chain gears. In addition to the vertical motion, the platform can rotate about its vertical axis to ease driver access and/or accommodate building plans. In selecting lift equipment, the building designer typically relies on specifications available from equipment suppliers. People movers. An automated people mover (APM) is a fully automated, grade-separated mass transit system. An APM system typically serves relatively small facilities such as airports, downtown districts, or theme parks, but is sometimes applied to considerably more complex automated systems. It may use technologies such as monorail, duorail, automated guideway transit, or magnetically levitating method. Propulsion may involve conventional onboard electric motors, linear motors, or cable traction. APMs are common at large airports in the United States.
Material handling equipments.
Material handling equipment. Material handling equipment is a mechanical device used to move and store materials and goods. This equipment consists of trolleys, conveyors, forklifts, automated storage or retrieval systems, cargo and baggage handler carousels, rail-guided vehicles, automated guided vehicles, intelligent flexible modular conveyors, pick-up and place units, and overhead hoists and cranes. In selecting material handling equipment, the building designer typically relies on specifications available from equipment suppliers. Some of the material handling equipments:
Paternoster.
Paternoster. Paternoster. A paternoster is a special type of elevator consisting of a constantly moving chain of boxes. A similar concept moves only a small platform, which the rider mounts while using a handhold, and was once seen in a multi-story industrial plants. Passengers can step on or off at any floor they like. Today, the installation of new paternoster is no longer allowed because of their inherent danger.
Shuttle transit.
They use standard gearless machine drives and cable equipment to operate. The cable is attached to the side of the shuttle car. A steel guide and power rails are adjacent to the running surface, where the vertical load is supported by air cushion pods at the bottom of the car and guideway. The guideway running surface can be single or double lane track. Shuttle services offers services such as circulating shuttles, demand response paratransit, special mobility services, and GT services. Shuttle transit is a public transport that consists of a bus, train, or airplane that flies back and forth between 2 points. It includes a variety of paratransit services that use buses or vans to provide public mobility. Shuttle service are fast and efficient means of transportation where the distance are impractical to work.
Cranes and hoists.
Crane and hoists are both lifting machines used to move heavy materials. The only difference is that a crane is a complex machine that lifts, lowers, and moves heavy loads. Cranes are equipped with components that provide the crane's multidirectional mobility, while hoists is a machine that performs a single task, lifting and lowering a load on a vertical plane. Hoists are situated on a primary horizontal beam of the crane called the bridge girder. Other types have an independent structural system and are much more versatile because they can move from one side to another. Like an overhead crane is attached to two fixed overhead tracks, and monorails have the hoist slung low below a single steel track. Gantry crane is a typical crane that is capable of lifting several hundred tons at a time. It is operated with controls located in an operator cab mounted to one of the structural steel legs.
Pneumatic tubes.
Pneumatic tubes is a technical equipment in which cylindrical containers are propelled through a complex network of tubes by compressed air or by vacuum. They are used for transporting physical objects. It is computerized to serve many purposes. They transport tube-like carriers, typically 3 and 3/4 to 5 and 3/4 inches in diameter and 15 to 16 inches long. Another pneumatic system used in hospitals and hotels is larger and used to transport linens or trash.
Conveyors.
A conveyor system is a common piece of mechanical handling equipment that moves materials from one location to another. Conveyors are especially useful in applications involving the transportation of heavy or bulky materials.
Some types of conveyor systems are gravity roller conveyor, gravity skate wheel conveyor, belt conveyor, wire mesh, plastic belt, belt-driven line roller, line shaft roller conveyor, chain conveyor, and screw conveyor. Conveyor system moves materials from one place to another within the building. They allow quick and efficient transportation for most materials that make them popular in the packaging and material handling industries.
In designing a conveyor system, here are the things that needs to be considered or acknowledged. Capacity requirement, length of travel, material characteristics, processing requirements, life expectancy, and cost. Main elements of a conveyor: conveyor drive, conveyor motor, auxiliary equipment, control of conveyors. Shown in this picture is the conveyor belt of an automatic book sorting system at a public library.
Thank you for viewing.